Hello everyone, today we are going to solve question number 92, reverse linked list 2. Given the head of a single linked list and two integers left and right, where left is less than equal to right, reverse the nodes from the list from position left to position right and return the reverse list. Okay, so you can see here in this image that the question requires us that will be given two positions left and right. In this case, left is 2 and right is 4. One thing that we can see here is it's a one based indexing. So 1, 2, 3, 4, 5. Okay, so left is 2, right is 4. We start it and we reverse this 2 to 4 part and then we just append it. Okay, so this is in this video I'm going to discuss 2 to 3 solutions for this problem. Okay, this is a base case. You can see if not head, basically if head is equal null, although it's not possible because number of nodes equal 1, so we can just remove this. Other case is if left equal right. In that case you have to return head. Why return head? Because uh, if we have left equal right, so in any case we just have to reverse one node, and reversing one node, it's going to stay the same. Okay, hence we are going to return head. Okay, so why I've written reusing old solutions is because the majorly this question can be broken down into two pieces. First one is going to be this isolating of this list. Okay, this 2 3 4, this isolation of this list that needs to be reversed, and second part is going to be reversing this list. Okay, so first part is isolation, second part is reversal. Okay, and to reverse this list, we have already discussed 2 to 3 solutions and reverse list linked list 1. Okay, so in that video we discussed brute force approach, recursive approach, and iterative approach. The iterative approach being the best one. Okay, so we are reusing the same approach. Okay, you can see here I've already written one function to ease time. Okay, so this function is literally the same function from here. Okay, it's literally the same function. There's only two or three corrections over here. Okay, what you can see is our return type is pair. Okay, so basically we for after reversing this we are going to return a head and a tail. Okay, so we are returning two things, hence a pair. Okay, and this fail safe case, so two nulls. Okay, and to store this newly formed tail. Okay, to store this newly formed tail, we are storing it in the initial phase. Okay, and in the end we are just returning it. In our original reverse list case, after reversing, the return type was we were basically returning head. In this function we are returning head and tail. Okay, so that's the difference. We can just keep it a black box for now. Let's see uh, the first method where we are reusing this old solution. Okay, so the goal of this taking this question is modularity and linked list arrangement manipulations. Okay, so basically let's see the first method. The core idea behind this first method is going to be isolate the list that needs to be reversed and then reconnect it. Okay, so basically what you have to do is isolate the list by storing before and after parts, before part being 1 and something before it, and after being 5 and after all the nodes after it. Okay, then we will be reversing the nodes in between, and then we are going to reconnect them. Okay, so before's next is going to be head, and tails next is going to be right. Okay, so this way we have to reconstruct a linked list. Okay, so you can see some visualization here that we had this linked list. Now after the first step, it's going to look like this. We have stored a before left, we have stored an after right, and this is a linked list that we need to reverse. Okay, after step 2, we have successfully reversed our list using our old solutions. Okay, after this we'll just connect this. Okay, so before's left's next is going to be head and tails next is going to be after right. Okay, so that part is going to be connection and we finally receive a final answer. Okay, so let's code this one. basically we have this reverse list part already solved for us. Okay, so our main objective right now is going to be isolating this list. Okay, so one thing that we can see that there could be a case where we have to reverse the head too. Okay, the left is equal to 1. In that case, we have to reverse head also. So for that reason, I'm going to use dummy. Okay, a dummy variable or dummy node that I'm going to create that I'm going to connect to head. Okay, so dummy dot next is going to be address of head. Okay, oh sorry, we can directly use head, and now we'll store the previous of left or the before left part. Okay, so list node star before left is going to be address of dummy. Okay, in the beginning, and then so one thing that might come in your mind is how can I iterate over this to make sure that my pointer reaches to perfect position. Okay, so in that case you can see here I is less than left I plus plus. Okay, we know that it's a 1 based indexing, so I'm going to start it with 1. Okay, so you can see before left's next is before is equal to before left's next. Okay, okay, so this is going to you can imagine like if left is equal to 2. Okay, in this case left is equal to 2 and we have a 1 based indexing, so I've started I with 1. Okay, initially my before left was pointing to 0. Okay, dummy or 0. Okay, so this loop is going to run for only one time. Okay, because for the next iteration I is going to be 2 and the left is I is less than 2 not equal to, hence it's going to run only one time and I'm going to reach my destination for this example X. Okay, so before left is has reached its original position. Now I'll have list node star, you can name it as uh, left 1, or you might name it as head 1, or you may reverse head. Okay, uh, the thing that we need to reverse and it's head. Okay, it's going to be before left's next. Okay, now I'll also need to point my pointer list node star reverse tail is equal to reverse head for now. Okay, for now. Now I have to place this reverse tail to its correct position. So I have to position this right, or you can say reverse tail to this position. Okay, so for that I'll do for int I equal to left I less than right I plus plus. Okay, so you can see left is 2, right is 4. Okay, so this loop is going to run for 2 times. Okay, now since I have initialized my rev tail with 2, so for after 2 iterations it's going to reach 4. Okay, so it's going to be rev tail is equal to rev tails next. Okay, now since we have our 2 pointers exactly pointing to right positions, now the only thing that we need is to disconnect them. The first thing I will disconnect it over here. So before left's next is equal to null, and also here that rev tails next is equal to null. Okay, now what I need is I have to mm, pass this isolated list to this reverse function. Okay, so since I will receive a solution from it, so I'll write a solution pair. I'll just copy this pair of list star solution is equal to this function reverse list, and I'm going to pass a rev head. Okay, so this is, I'm going to pass this head to this list. It's going to return me two things. Solution dot first is going to point to new head, and solution dot second is going to point to new tail. And why this is because we have programmed it that way. Okay, so first we are returning head, then we are returning tail. Okay, so now the third step is, since we have reversed it and we received a head and tail, now the thing is that we have to connect them. Okay, so before left's next is going to be head. So before left's next is going to be solution dot first. Okay, next part is tails next is going to be after right. Okay, so tails next, how to get tails next is going to be solution dot second. So we have received tail, and tails next is going to be after right. But you can see we don't have an after right. So what we are going to do is we are going to store it over here, and we have to store it before disconnecting. Okay, so rev uh, list node star after right is equal to rev tails next. Okay, reverse tails next. Okay, so that's going to store a future list, and now I've connected it. Now in the end I can just return dummy dot next. Okay, so this way we have solved this. I think so everything is fine. Let's run this. So received a compiler error. Okay, it's because there's something issue here. Okay, we forgot a pointer over here. Okay, let's run this. Okay, let's submit this. So this was the method. The method takes a time complexity of O(n) and space complexity of O(n), although all the methods in this question are going to take the same time complexity and space complexity. Okay, it's all about modularity and reusing these codes. Okay, so let's see for the second method. Okay, now the optimization part for this problem. Since we have done the previous part very thoroughly, now the optimization for this might be that you might be called that you cannot call any other function and you have to do all the operations in place. Okay, so in that case, the majorly the changes are in this section where these three are now uh, not of use. Rather, we have to use the same function. Okay, I'm going to use the same part again. Okay, and this time we are not going to return anything. Okay, this time we are not going to return anything. I have copied it, I have pasted it. Okay, so current is going to point to head. Rather than pointing to head, it should point to reverse head. Pointing to tail, reverse tail, or reverse head. Okay, current. Okay, these are the three variables that we defined inside this recursive function, and it was passing we were passing head to it. Now it directly takes reverse head from the last part. Okay, the reverse head was this two, or you can say the head of the list that we need to reverse. Okay, now what we need to do is, for this we have after this after this while loop, what will return is these two things. Okay, reverse and tail. So basically head and tail for the reverse part. And you can see the connections here that we simply had these two connections. So I'm just going to copy them and paste them, and I'm going to uncomment them. So before's next was pointing to new head, and from this while loop our new head is going to be previous. Okay, and for this solution dot second, it was our tail, so I'm going to point it to tail. Okay, so that should be the optimization part. So after this we don't even need this function. We can just comment it out. We don't need this function. and can also remove this for me better. Okay, so that should do it. Let's run this. Okay, let's submit this. So the core optimization was nothing. The method was obviously the same. Construct the dummy pointer. We are going to point to storing before left, storing after right. This was always the same. The major changes was just using that above function inside this function so that we can do inside the same function. We don't have to call anything recursively. Okay, so that's it. Let's see the optimal solution for this problem. So now we are going to solve this question using the optimal approach to solve this problem. Okay, this method is basically we are reversing this list using another method. Okay, so what this method says is we are inserting the next element and inserting this element to the head of this list, and we are doing this continuously till we reach the end of the list. Okay, this is the main concept behind reversing this middle part. Okay, so that's the only thing that's going to change. Okay, so first let's discuss how this method works. Basically, the core idea behind this is going to be isolate the list that we need to reverse, then insert at head till the current head of the reverse list reaches the end of the list. Okay, or you might say that uh, till a certain specific time, because since we have left and right given to us, we already know how many times we have to move this to reach to the end of the list. Okay, so tasks in this method are going to be isolate the list while storing before and after parts, reverse by inserting new element to right, reverse head to head. Okay, so basically we are inserting just the next element recursively. Okay, and then we are reconnecting finally to these left and right parts. Okay, so you can see the example here that first we are from this list we are storing a before left and an after right. Okay, then we'll have this these we'll reach the starting the left part. Okay, we'll reach here and then we are going to recursively uh, insert this to this position. Okay, and how we are going to do this is using these three steps down below. Okay, first step is going to be storing the future elements. Okay, so by this you can see uh, 2 is pointing to 4. There will be a certain case where 2 will be pointing to 5. In that case we have to stop. Okay, next we are storing a future. Second, we are reconnecting this nodes to already existing head. Okay, since we are inserting at head, so the nodes next should point to current head. Okay, then we are reconfiguring the head for reversing the list. Okay, so since we know that this is our new head, before's left should point to new head. Okay, these are the three major steps that we have to do. So it should look like this in code. Okay, we'll code it later. And after this all part, we can see we have successfully inserted one of the node inside to the head. Okay, now again we are going to do this for 4. Okay, so repeat this process till current reaches the end, or you can say current next is equal to null. Although this condition is good if we are reversing the whole list, but since we are not reversing the whole list, this is not the condition. The better conditions, rather than writing a condition, we can directly count the number of times that we have to uh, pass on to this function, or basically we have to insert at head. We can count it by using right and left. Okay, so this after this iteration our currents next is going to point to 5. This node is going to be inserted at this position and before's left is going to point to 4. Okay, so after these configurations our node should look like this. Okay, you can see our node should look like this: 1 4 3 2 5. Okay, this is our final answer. Okay, so that should do it. Let's code this one. So basically first thing that we'll require is list node dummy 0, as obviously because there's a chance that we have to reverse our whole list, or maybe head to. Okay, then dummy dot next is equal to head connected or dummy next will need list node star before left, and I'm going to initialize it with dummy. Okay, because there's a case that we have to reverse head. Next, I'm going to move this before head. So for int I equals 0, or you might say I equal to 1 because this one based indexing, I less than left, I plus plus before left is equal to before left's next. Okay, next thing that we have to do is we'll need a current. Okay, as you can see here, we stored a current. Okay, so we'll need a current. So list node star current is equal to before left's next. Okay, so now we are pointing to current. Now to know how we are deciding this, I equals 0, I less than right minus left, I plus plus. You can see why we are doing this specific number of times is, you can see right's value is 4, left's value is 2, so right minus left is 2. Okay, and you can see here in this version where for one insertion, for second insertion, after second insertion we can finally get our answer. Okay, same way right minus left is 2, so from 0 to 2 it's going to be 0 and 1. So for 2 iteration this loop is going to run. Okay, so now to follow up for this node, we'll need a temp to store a current head. Okay, or maybe you can say the new head that we are storing, the node I have named it as temp. Okay, temp is going to be currents next. Okay, yeah. We now what you have to do is we are going to store future, so currents next is going to be temps next. Now we'll insert, or you can say uh, connect to current head, so temps next is going to be current, or better you can write it as before left, not current. Okay, before left's next. Why? Because before left is always going to point to our original head. Okay, next part is going to be marking this as our head, marking this as new head. So this is going to be before head, sorry, before left's next is going to be temp. So by this we have marked this as a new head. Okay, in the end we have to just return dummy dot next. Okay, so this should do it. Let's run this. Okay, let's submit this. So we have solved this question using this optimal solution where we are recursively inserting the next node to head. Okay, so that should do it. Let's see in the next video.